Imagine copying a paragraph of text, like something you just brainstormed with an AI, pasting it into a private offline document, and, well, realizing there is an invisible barcode permanently tracking it.
Yeah, just completely baked into the text.
Right. So today we are taking a deep dive into your text sources from August 13th, 2026. We're on a mission to decode how this aggressively accelerating AI compute speed is colliding head-on with astronomical IPO valuations and permanent global regulation.
Because the underlying mechanics of how these systems are built, funded, and governed, they're all fracturing and rebuilding at the exact same time.
Exactly. Let's jump straight into the infrastructure speed race. Raw performance is basically the primary battlefield for AI dominance right now.
Right, it's all about speed.
Yeah, I mean, OpenAI's GPT 5.6 Sol ultra-fast mode just hit 750 output tokens per second. They're using these Cerebra's wafer-scale chips to do it.
Which is what, 14 times standard speeds?
Yeah, 14 times standard industry speed. On the exact same day, Anthropic is negotiating a $6 billion acquisition of Descartes AI just for GPU tech that runs models at 8 times the average.
That's like a Formula One race, but the teams are forced to invent their own fuel.
That is a perfect way to put it. But I have to ask, I mean, for those of us not building data centers, what actually is a wafer-scale chip? Why does it enable this kind of velocity?
Well, normally, data centers string thousands of small chips together. The bottleneck there is just physics. It's the physical time it takes for data to travel over tiny wires between separate chips.
Right, okay.
But a wafer-scale chip doesn't slice the silicon up. It is one massive, like dinner plate-sized megachip.
Oh, wow.
Yeah, so the data never has to leave the silicon, which drastically cuts down transit time. That efficiency is that you hit 750 tokens a second.
Okay, but I want to push back on this a little bit. Is 750 tokens a second just an industry vanity metric?
What do you mean?
Like, is it like a car speedometer that goes to 300 miles an hour when the limit is 65? Does this actually unlock fundamentally new real-time applications for you, the user?
Oh, absolutely. I mean, think about the rise of autonomous multi-step agents. Like, DeepSeek just launched their V4 Pro coding agent.
Right, and they're looking for $8 billion in new funding specifically to expand their compute infrastructure for that.
Exactly. Because if that AI has to execute 20 sequential steps in the background to troubleshoot your code, standard wait times compound.
Ah, so a 2-second delay on each step becomes nearly a minute.
Right. 14 times the speed removes that bottleneck. It makes real-time, complex, autonomous actions actually viable without the system timing out or the user just abandoning it.
Which explains why building these massive, ultra-fast compute engines requires immense capital.
Yeah, it burns an ungodly amount of cash.
And that's forcing AI labs into hyper-monetization and public market debuts. DeepSeek is aggressively monetizing hiking V4 Pro API prices to nearly $4 per million output tokens during peak hours.
OpenAI just hired Dolly Radjic as Chief Revenue Officer, too, to scale enterprise sales ahead of an anticipated IPO.
And then there's Anthropic. They're eyeing a staggering $2 trillion October NASDAQ IPO fueled by $10.9 billion in Q2 revenue.
$2 trillion is just a massive number.
It's historical tech giant territory. I raise an eyebrow at that because let's do the math. A $2 trillion valuation on roughly 120 billion annualized run rate.
Right.
I mean, yes, Google's Gemini just crossed 1 billion monthly active users, proving the consumer market is massive. But does 120 billion run rate actually justify a $2 trillion price tag?
Well, it does if you stop looking at Anthropic as a software company. Investors are pricing these labs as foundational utility-scale infrastructure.
Oh, interesting. So not just software.
Right. They aren't just selling a chatbot. They're selling the 21st century equivalent of the electrical grid. That valuation assumes AI compute will literally be the underlying power source for the future global economy.
Wow. But, with billion user scale and massive public market valuations comes inevitable regulatory scrutiny.
Definitely.
To comply with the EU AI Act's transparency rules, Anthropic now globally embeds a machine-readable, imperceptible watermark in all Claude-generated text. But how does that even work? How do you hide a barcode in plain text?
It happens at the model level through probability. When the AI generates a sentence, it's constantly predicting the next most likely word, right?
Right.
Well, the watermarking algorithm subtly skews those choices toward a mathematically specific vocabulary list. To your eyes, the sentence reads perfectly normally.
But a scanner checking the statistical distribution of the words can instantly verify if the text aligns with that hidden pattern.
Exactly.
So because the signal travels with copy-pasted text, this has sparked massive developer debates about user privacy.
Yeah, it's a huge issue.
It's like an invisible barcode attached to your brainstorming. Doesn't this global tracking ultimately damage user trust?
That tension is driving the whole debate right now. The technology scaled so fast that compliance requires blunt force tools.
So, solving the regulatory mandate for transparency inadvertently creates a permanent surveillance infrastructure on user brainstorming.
That's exactly the privacy cost we're looking at.
Well, we are clearly watching speed, unprecedented capital, and regulation collide in real time, which leaves a final provocative thought for you to mull over.
Yeah, what's next?
Right. If models are running 14 times faster and watermarking absolutely everything, will the future internet just be autonomous AI agents instantly talking to other AI agents, scanning each other's invisible watermarks to verify who they're dealing with?
That is a wild thought.
We humans might just end up sitting in the grandstands.